to welcome you to the latest updates on where we are with agents managing networks. In November of 2025, I entered a Gemini hackathon with a team of agents that was able to monitor a data center, detect failures in real time, investigate those failures, resolve those failures, and restore services, all within a span of seconds. And what I want to show you today is um, what we started with in November of 2025 and where we are now. If we look at where we started, this was the original team of agents, the original solution. Um, and what you have here is, as we described, um, a investigation coordinator that responds to a failure. We're using end-to-end ICMP pings to uh, monitor the health of the EVPN end-to-end. When the coordinator needs to start the investigation, it invokes investigators at each stage of the data center protocol stack. So you got an EVPN service investigator, you've got an IBGP investigator, and you have other investigators. When the investigators are all done their work, the resolution coordinator works with a human to resolve those issues and bring the service back into operational state. I found that this solution had a few limitations. The first limitation was that it was not able to recover from hallucinations. And as we know, hallucinations in large language models are prevalent. They happen often. So this implementation was not able to detect hallucinations or other failures. They could be failures with trying to push the configs down to the network. It was not able to handle that either. Also, the investigation coordinator and the resolution coordinator have been overloaded. They have too much responsibility. The investigation coordinator in this implementation is managing all the investigators, and you have a single resolution coordinator fixing all the issues for all levels of the protocol stack. One thing I've learned in my experience with working with agents is it is very useful to think of an agent as a human. How much responsibility do you want to give the human? How much responsibility can you reasonably give to a human? Similarly, we have to ask that same question of our agents. The strength of this solution is that the resolution coordinator works with a human before it makes any changes to the network. That is critical. Networks are critical infrastructure, and so the coordinator must get human approval before making any changes in the network. We discussed this in a lot of detail in the original implementation. I will make that original video and resources, including the source code, available in the top right of this presentation. So on to V2 of the implementation. This implementation took all the learnings that we concluded from the first implementation, and it improves on them. So what you see in this implementation is a manager working with a worker. And You've got these loop flows that are making sure that if the worker hallucinates, if there are failures, the manager is able to detect and push once again the request to complete the task. Now you've got multiple loop flows here, as you can see, in various stages of the investigation, troubleshooting, resolution. And this is a very chatty agentic flow. What I found was that it is very hard to troubleshoot because at different times you have different failures. We know LLMs hallucinate, so different agents suffered from hallucinations at different times. And because you've got constant looping of this flow, to push it to completion, the token usage was very high. So there was room for improvement. Which brings us to V3. This is the solution that we will present today. You will see a live demo of this solution in action. It improves on the deficiencies of V2 and V1, and it brings in further improvements. We'll talk about future improvements beyond V3 at the end of this discussion. So what you see here is I've introduced workflows that breaks up the chattiness and the purely agentic communication from agent to agent. Now you've got old-fashioned programming, old-fashioned code that connects the one part of a flow to the other part of the flow. And I'm bringing it all together using state objects so that when we transition from one part of the flow to the other part of the flow, when the agent is invoked, it can see using the state object what was done and what is being asked of it, right? And the state object is shared among all agents on the in the flow so that everybody is aware of what was done and what needs to be done. This allowed me to simplify the implementation, and it gave me room to add even further improvement to the implementation. So what you see here is a end-to-end configuration verification agent. It's looking at the end-to-end EVPN service and verifying, is the EVPN service configured correctly? That's the first part of the EVPN validation flow. The second investigator is looking for failures on a per site basis. So for those of you who are aware of Yang, the top half of this flow is looking at Yang configs. The bottom part of this flow is looking at Yang states. Now for failures that the end-to-end investigator finds or the site investigator finds, a site resolver is invoked for every one of those failures. So we're not overloading the resolver. We already have a per protocol resolver here. We also have multiple different resolvers for different problems. So we are not overloading our agents anymore. We're allowing them to focus on the task that they need to complete. What is also really what is really an improvement in this implementation is you can see here the end-to-end config investigator can work with a human being. We will see that conversation happening where the investigator needs clarification or where the investigator finds an inconsistency in the EVPN service end-to-end. And the resolver We've seen this. This is consistent. The resolver must check with the human before it makes any changes to the network. So what you see here is that we have our process running already, and it's monitoring the EVPN, and in the log on the bottom panel, we are seeing that the EVPN is healthy. It works end to end. So what we're going to do is we're going to introduce a couple of failures. We're going to mess up the config for one scenario, and we will also bring down an interface. And what we're going to see is how the agent team reacts. Okay, so we're going to make a couple of changes. And what you can see already is from the logs, the agent team has already detected the issue, and it's already started investigating. And you can see faster than we could type, it's already presenting that it's found an issue, and in this case, there is a inconsistency in the route targets on the EVPN, and it's asking us which one do you want. So I'm going to clarify that we need what 100:1. And as part of this implementation, the prompt instructs the resolution agent and the investigation agent, by the way, to ask twice so that we are sure that we're going to be making these changes. And what you can see as well is we're using the intelligence of the LLM to determine the Yang path and the value that it needs to deploy. We are not hard coding every use case that we can think of. We're leaving it to the intelligence of the LLM to decide what it needs to change and how it's going to change it. That makes a human in the loop important. So we can see here that the flow has moved on to investigating the upper states of the sites. And as we would have hoped, right, and expected, the agent team has found the issue with the interfaces. And so, yes, let's fix that issue. Again, it's going to ask twice. So we can see here the team is finding that it has not fixed the issue yet, so it is trying to figure out what else is going wrong. Okay, so it's found an export or an issue with the route target. So let's have a conversation. So what we're seeing here is, for some reason, the original attempt at fixing the issue didn't work, and we're seeing that the team is robust. It has come around. It's detected that there's still a failure, and it's trying to fix the issue a second time. Looks good. Confirmed. Let's see if you're able to see how the deployment is going. Well, there we go. We're seeing that the deployment was successful the second time, and we finally resolved the issue. So you can see here the agent team is fast in detecting a problem. It's fast in working with a human to resolve the problem, and it is robust. We saw here that there was a failure. I would need to take a look at the logs to see what happened when it, on its first try to resolving the EVPN. But you can see it didn't give up. It continued, and on a second attempt, it was able to correct the route targets, and the EVPN is once again operational.